All right, good morning, pre-calculus. Today is Wednesday, March 25th. We're doing 7.2 addition and subtraction formulas. Now, I did leave 7.1 on the back wall. We're just going to reference a couple of those basic trig identities in the corner. So 7.2 addition and subtraction formulas. Now, if you also have your unit circle, I gave you one in class. You created a couple of your own in class. You have the returned quiz of this. You should have many of these copies floating around in your math book or notebook or folder. So pull out one of these. If you can't find it, just print one, Google one. It'll make your life easier. Alternatively, you could make a new one since you guys are experts and you do know how to do that now. All right, a couple things. Continue practicing for your ACT, SAT. Abby, great job. You're going to get a merit because I saw you logged into Khan Academy for practicing your ACT questions over an hour last week. Nice job. You guys can do that. If you still have any college advising questions, you can email Mrs. Michelson still, cmichelson@stmichaelpetoskey.org. Or email me and I'll get the message to her, the question to her as well as Mrs. Nolan could be of help for that too. So maybe CC all of us and we'll get that question answered for you, any of those college advising questions, okay? Keep practicing with that Khan Academy. You should have logged in. Juniors and seniors have done this with Mrs. Nolan and you linked up your, I think it was SAT results, so that Khan is actually catered. You can study by subject of what you need improvement most on. If you need help with that, email Mrs. Nolan and myself and Colleen Michelson and we'll get that figured out for you. So that's that. And then grades. So I'm working on it. I'm exhausted. This is way more work than in school, so I am behind. And if you saw, Dr. Brake emailed parents, what we're doing is your quarter 3 grades are going to end on March 13th. That was the last day we were in school. So anything that was taught to you in a seat at SMA will be counted for quarter 3. And then all this online stuff that started last week, Monday, that's going to be counting in quarter 4. And it just makes everybody's lives easier. Okay, so I'll be putting these grades starting last Monday. Those grades are going to go into quarter 4. I don't know if you can view quarter 4 yet because that's not technically the date it's supposed to start after spring break. So I don't know if you can view it in RenWeb yet, but you will definitely be able to view it after spring break for quarter 4. I will give quiz results and some feedback soon. Last time I checked, I'm still missing 2 people on the quiz, which is okay. I know a couple of you were behind on getting those homeworks in, and I want you to master the homeworks and the lessons and watch all the videos before you take that quiz, so that's okay. Secondly, on times, I know I've been getting these up a little later than you want. I've seen that feedback in emails. I do apologize. I am trying to get these up as soon as I can. It's just a lot of extra work. I'm sorry. So if you guys would like to, you can have an extra day. If I don't have the video up in the morning of that day, take an extra day to get the homework in. That's fine. I'm not going to count that late points. In fact, this whole last week, I didn't count late homework. It's just, I was getting things up late. You guys are getting into the swing of this. So if your homework was turned in a day late, or 2 days late, I'm not counting that against you. Okay, I will count it against you if your answers were just gibberish, guesses, or I don't know for every single one. I'm not counting those. And you can submit a homework a second time. Okay, if you realize you learned something later and you want to go redo it, maybe you're just practicing for a quiz, you can go back in those homework forms. Those will always be open and posted in the lesson plan. I'm not going to delete them. I'm not going to put a deadline or a cap on them. You'll always be able to access those and be able to see what was inside any of those homeworks and classworks. Okay? All right, so let's get started on 7.2. We've got the addition and subtraction formulas. Now, I'm going to do a little demonstration. We're adding 2 functions together. Kind of crazy. I'm going to give you a visual representation of that first, and I don't want you to worry about drawing this right now. I just want you to watch what's happening. We've got 2 functions here that you should be very familiar with. The black is the standard sine function. We haven't changed anything about it. Its amplitude is still up at 1. That's the curve in the black pen. And then for cosine x, we've just changed the amplitude from 1 to 4, and you can see that very clearly. It starts up at 4 and ends up at 4. So we're going to add those two functions together. Now, adding is quite simple. You keep the same x. You look at those x's, keep the same x, and you add the y's. You add the outputs. So if you were looking at, say, this very first point when x is 0, we have 0 for the sine function and 4 for the for cosine. So 0 plus 4. Add them up, you got 4. At a half pi, we've got 0 plus 1, giving you 1. At pi, we have 0 plus -4, giving you -4, and so on. So you add those together, and I've done that in the pink here. We've got the 0 plus 4 we talked about, the 1 plus 0, and the 0 plus -4 that we talked about, those first 3 pink dots, and carry on the pattern. And you've added your two functions together. Okay, you do not have to copy this down. We're going to go through one more function of adding two functions together. Next example are two functions that we're adding together that each have an amplitude of 2.5. Our sine function and our cosine function have an amplitude of 2.5. So we see the sine function, instead of being up at 1, it's up at 2.5, and the cosine function, instead of starting at 1, we're starting at 2.5. Now we're going to be adding the same points like we did in the last example. So when x is 0, we're going to add 0 plus 2.5 to get our new pink dot at 2.5. And then at a half pi, we're going to add our 0 plus 2.5 and get a pink dot at 2.5. Now, if we were to only do those same intervals that we used last time, those 4 positions, well, 5, if you count 0, we wouldn't get enough information. In this case, we're going to have to pick a point halfway between these two because, as you see, each graph is about 2. Sine function and cosine are both at about 2, so 2 plus 2 is 4. So we're going to get our resulting graph. We'll have a dot up here at about 4. And then next dot, we've got a point down at -2.5 and at 0, which add up to a -2.5, so we'll put a pink dot there. Now we need to do another point in between these two. I have one at about -2 and about +2. -2 plus +2 gives us a point here at 0. So we'll repeat that for all those other points, as well as a halfway point in between them. And you'll get a resulting graph that looks like this. I'll leave it up for you to study for a moment. Okay. Now, the two graphs that we just discussed, they had, this one had an amplitude of 2.5 and an amplitude of 2.5. They add to 5. And then last example we did, we had an amplitude of 4 and an amplitude of 1, which adds to 5. And you might think, oh, well, if we're adding, you just add those amplitudes. And as we saw, those two resulting functions, they don't necessarily look like that, although it does kind of look like amplitudes are both 4, about 4 there of our pink, and an amplitude of about 4 there for our pink one there. Now, it turns out that they're close to that, but not actually exactly. And our fun fact here, you now know how to add the graphs and what that's all about, but some brilliant mathematicians got together and they figured out formulas. So you don't have to actually add graphs, which actually aren't that accurate. I mean, we're only estimating. So they came up with all these formulas on page 535. Mark it, tab it, you're going to use it. I will provide these for you, or you will be allowed to use them on quizzes and tests. You do not have to memorize them, however, you do have to know how to use them. So you'll also have to work these backwards. You might be given the right-hand side and recognize the right-hand side, and then work it to get to the left-hand side. Okay, so both directions there. And when we do the formulas for those first two things that we added, it turns out for our first function, this doesn't give us a proper bearing. For the first function, when you plug in to the formula, first set of functions, and you plug into the formula, you're getting about 4.12, and when you do the second two-function example, you get about 3.54. So those amplitudes we estimated at about 4. Our estimate was our estimate, but these are the exact answers from the formula. So we like the formula. It's faster, and you get the exact answers. So you will not be drawing functions for your homework. You will be using the formula. Here's a quick recap of how do you find the sine and cosine and tangent positions on the unit circle. So say you are either given 60 degrees or you're given a third pi. So you find what that coordinate is on the unit circle. If you're asked for cosine of 60 degrees or cosine of a third pi, you're going to look at the x position of the coordinates, so it'd be 1/2. If you're asked for a sine of either 60 degrees or a third pi, you're going to go to the y position, so you'd have square root 3/2. And then for tangent, remember it's sine over cosine, so you're going to take the y position over the x position. So you have square root 3/2 divided by 1/2. That's a fraction divided by a fraction. So keep, change, flip, or copy, dot, flip. And you're multiplying straight across the top, straight across the bottom. Pair of 2's cancel. You have square root 3 for that example there. This is example 1A on page 536. So you're going to be given just the left-hand side. Your homework will say just cosine 75. So we don't like cosine 75 because that's not easily accessible on the unit circle. I don't see 75 on there. So we're going to break down 75 to be 30 plus 45. Pretty simple. Sometimes you may have to subtract two numbers, or you may have to use a common denominator and reduce fractions. For that, we'll practice that one in a minute. But just think of what two numbers can you add or subtract to get to the given degree or to get to the given radian. Some of your problems will give you a radian here, and we will practice that one in a moment as well. So we've determined cosine 30 plus 45 works, and you're going to look at your formulas and find the addition of cosine. So cosine s plus t in parentheses there. And we're going to rewrite that formula and replace the two numbers in each of those positions there. So you've got cosine of 45 and cosine of 30. I flip-flopped those. But the cosine times the cosine of each of those two minus the sine times the sine of each of those two numbers. Okay, this is just plugging into that formula that we're given. And then we go to our unit circle. We need to know when is cosine and sine at 30 and at 45. So we've got, here's our 30 degree, here's our 45 degree. So when is our cosine 30 degrees? You're looking at the x, square root 3/2. And when is our cosine 45 degrees? Look at the x, square root 2/2. When is our sine 30 degrees? Look at the y position, 1/2. When is our sine 45 degrees? Look at the y position, square root 2/2. So I've replaced each of those numbers with the equivalent there. So as we just read off, cosine 45 is square root 2/2. Cosine 30 is square root 3/2, and so on. Keep your multiplication and your addition or subtraction signs. That's part of the formula. And now it's just a fraction times a fraction. And fraction times a fraction, you multiply straight across the top. And straight across the bottoms for those. So straight across the tops, square root 6, square root 2, and straight across the bottoms you get 4 on the bottom and 4 on the bottom. Now those are like terms. When you have like terms, you can add the numerator. So you get the square root 6 minus our square root 2 all over the 4, the common denominator. Can we combine those? No, they are not like radicals, cannot combine them. If there were pairs of something that you could take out, if this was square root 8, you would reduce it, but in this case we can't reduce it. We're done. You're just done at that point, okay? Next example, we're going to take a look at example 1b on page 536. So in this one, we are given cosine of 1/12 pi. 1/12 pi, well, so you'll only be given that, right? You'll be given just 1/12 pi. So ask yourself, well, what two things can I add or subtract? It's going to be pretty hard to add two things to get 1/12. So pretty clearly you should guess, well, it's probably going to be subtraction. And I would start with this. Keep the same base. So 3 minus 2 would give me 1, and I want 1/12. So 3/12 minus 2/12 gives me 1/12. Cool. Let's reduce those. 3/12 is 1/4. 2/12 is 1/6. And we like these. These occur on the unit circle. And so this is a cosine, go to your formulas, cosine with subtraction, s minus t. So find that formula, cosine s minus t, and copy it down. Then we're going to plug into that formula, and for this example, I plugged in with our 1/4 pi and 1/6 pi. And then you guys just go to the unit circle in the same way that we did for the degrees. You guys are going to do that for the radians. So cosine, find a 1/4 pi. So it starts with cosine of 1/4 pi. Cosine would be the x position, square root 2 over 2. And then cosine of a 1/6 pi, x position, square root 3 over 2. And then sine of 45 degrees would be the y position, square root 2 over 2. Sine of 30 degrees is the x position, 1/2. And so I've replaced those with what those are equal to in the under the formula there. So we've replaced those, and then just like your last one, you've got a fraction times a fraction, and another fraction times a fraction, straight across the top, straight across the bottom. And you guys can add with having the like fractions there. You can add across the bottom. Can you reduce these? No. You would just end there. Okay. Happy birthday, Abby, in pre-calc. We didn't have a video yesterday, so we didn't get to show this yesterday. But happy birthday to Abby, also Anne and Isabel. If you guys know how to send them a snap or something, wish them happy birthday. Okay. So next we're going to do example 2, and this is looking like the right-hand side of one of the formulas we have. So it'll be given to you this way, find the exact value of the expression, and this recognize it, well, hey, it looks like the right-hand side of that formula, adding sine. So underlined in pink, that matches exactly, so I rewrote it below to match it up. So we rewrote it below, matching it up, and then if sine s is 20 and cosine t is 40, well, we're just plugging in right there. Our 20 plus 40 must be, which is easy. 20 plus 40 gives you 60 degrees. Yippee, we like that. And then look at your unit circle. So sine of 60, find 60 degrees, look at the y position, and you guys find that it is equal to square root 3 over 2, and you are done for that problem. Go ahead and pause this if you need to copy this down. I'm going to flip to the next example. Last example, hang in there. We are almost done. We've got to try one with tangent. So you'll be given, in this case, a radian. We're starting with 7/12. So either addition or subtraction, how can we get to 7/12? Because we don't readily or easily see 7/12 anywhere on there. So what two radians can we use and add together to get to that? 7/12. Well, first of all, I don't even see 12ths on there, so I want you to think about common denominators and reducing. So maybe something like trial and error, you'll figure out 3/12 plus 4/12 because those are going to reduce to 1/4 and 1/3, and we like 1/4 and 1/3. So with a little trial and error, you'll figure that out on your own, that you're going to get, those are going to be your two fractions that you'll be adding together. And honestly, that's kind of the tougher part of these problems, is finding out what are the two things you're going to either add or subtract. Once you get that, you're good. Okay, so what is your formula? for tangent, and first, before plugging in these into the formula, I looked at, well, what is a fourth pi and a third pi for tangent on the circle? Remember, tangent is going to be your sine divided by your cosine, so your y over your x for each of those. So I jumped ahead and did that for you. We've got 1/4 pi, look at the unit circle, is 45 degrees, your y over your x, and then copy dot flip to get a 1 for tangent 45, and then tangent 60 degrees, your sine over cosine, y over x, square root 3 over 2 divided by 1/2, copy dot flip, you get square root 3 over 2 times 2 over 1, which gives you just square root 3, okay? So I did that to save a little work. We're now going to just plug in with the formula using those two things. We'll plug into the formula with those. So I wrote down what is our formula for tangent adding two things, and we've got s plus t. So tangent s plus tangent t all over 1 minus tan s times tan t. So we've plugged in what our things are for that. We've got our 1/4, our 1/3, and we just did the work looking at the unit circle, our sine over cosine, and we found out what those values are. So our tan 1/4 is 1, we've plugged into the formula. Our tan 1/3 is square root 3, we've plugged that into the formula. Okay, and so for this, we want to rationalize the denominator. Remember, we don't like having radicals in the denominator, so we want to rationalize that. And how do I rationalize the denominator? I'm going to take 1 plus radical 3, and that's going to eliminate that in the denominator. So I've got, if I multiply that on the bottom, that'll help me get rid of that. Of course, I have to do that in the top because I'm only multiplying by the number 1, which is allowed. And now we have a fraction straight across the top and straight across the bottom. As we multiply those, so you're going to FOIL. As you FOIL, you see 1 times 1, giving you that 1. Middle terms, outside, inside, you got 1 times square root 3 and another 1 times square root 3 for 2 square roots 3. L lasts, so square root 3 times square root 3 cancels the radical to give you a 3. Let's move to the denominators. 1 times 1 gives you that 1. Your middle terms are going to cancel. You'll get positive square root 3 minus square root 3, giving you 0 there. And then lasts, yippee, we've canceled the radical. Square root 3 times square root 3 gives you that 3. And now we're going to combine any like terms, 1 and 3 giving you that 4, 1 and negative 3 giving you that negative 2. And then we've got a greatest common factor in this. We're taking a 2 out of the numerator, which I've taken the 2 out there, and I've just shown the denominator as 2 times negative 1. We get to cancel that 2 out. When we cancel that 2 out, we've got, this is what we're left with, and that negative in the bottom, we can just move that negative in the bottom up to the numerator there. And then the standard position is that you would write the radical last. So your final answer would be minus, so that negative 1 is outside, parentheses, 2 plus square root 3. You would have the radical come last, and that would be your final answer there. If you need to copy any of that, you can pause that there and copy that into your notes now. Go to RenWeb, it'll have your homework and some hints on the homework. Good luck.